In this lesson, we're going to look at how we can find the derivative of trigonometric functions. So here we have a graph of f of x equals sine x, which is the graph on the top, and we want to find its derivative. So by looking at the graph and knowing from the previous lesson on how we can sketch derivatives, we can see that wherever there is a slope of 0 is where the derivative graph will cross the x-axis. Also, wherever the slope is positive, our graph for the derivative will be above the x-axis, and wherever the slope is negative, the graph will be below the x-axis. So just kind of copying our idea of sketching the original to the derivative, we can see what the derivative of sine of x would look like. And what that actually is the cosine function. So using the definition of the derivative and the various trig identities, we can conclude that the derivative of sine x is equal to cosine x. And similarly, we can prove that the derivative of cosine x is equal to negative sine x. So we're going to go through some different trig functions and what their derivatives are. These are important to remember. Okay, so the main two that you definitely need to know are sine and cosine. You do need to know all of them, but I will show you in a little bit how you can kind of create them yourselves if you can't remember them. But the ones you need to make sure you remember are sine and cosine. So if we look at this example, okay, find the 27th derivative of cosine x. Now that sounds a little tedious. I'm sure we don't want to find the derivative 27 times. But let's start finding the derivative and then seeing if we notice any patterns. So the first thing I'm going to do here is I'm going to find the first derivative. So f prime of x. So we're going to just call this f of x, right? So f of x equals cosine x. So f prime of x is going to be the derivative of the cosine, which from the previous slide is negative sine x. So now if I want to find the second derivative, so f double prime of x, I'm going to take the derivative of negative sine x. Now the negative, you can think about that as being a negative 1 in front, so you have a constant of negative 1. The derivative of sine x is cosine x, so we're going to have negative cosine x. Okay, if I want to find the third derivative, again, I'm going to follow the same pattern here, and I'm going to say, okay, I have the previous function, so I'm going to take the derivative of that. Again, this negative in front is like negative 1. So we have negative 1 times the derivative of the cosine of x. So derivative of cosine is negative sine. So a negative sine gives us sine x. Okay, let's go to the fourth. So I'm going to do f to the little 4 there. So the fourth derivative of x, fourth derivative of f. So now we're taking the derivative of sine, okay, which is cosine. I'm going to go one more and do the fifth derivative. So I'm taking the derivative of cosine x. So that's going to give me negative sine x. So if you look at the pattern that we've created here, we can see that we loop back around right at the fourth derivative. So once we get to the fourth derivative, it's what we started with. So kind of like a shortcut, instead of having to do this 27 times, is to figure out that every fourth derivative, so every derivative that's a multiple of 4, is going to end up at the cosine of x. So if I have the 27th, so f 27, so the 27th derivative, if I had the 28th derivative, which is a multiple of 4, it would land here on the cosine of x. So it's 1 less than that, so it's going to end up being sine of x. Okay, so we're looking for a pattern, and we see that the pattern repeats after every 4. So instead of doing it 27 times, figure out the pattern, and then we can figure it out from there. Okay, here we're going to look at another example. We want to just differentiate this, so we're going to find y prime. Now this function here, there's an x squared and a sine x. They are attached through multiplication, so we must use the product rule here. So remember that the product rule is going to be the first times the derivative of the second. So first would be x squared. The derivative of the second, so derivative of sine x, is going to be cosine x, plus the second, which is sine x, times the derivative of the first, so the derivative of x squared, would be 2x. So I'm just going to clean it up slightly and just say that it's x squared cosine x plus 2x sine x. Okay, if I wanted to be super fancy and simplify it a little bit, I could pull out an x. So I'm just going to do that really quick. If I pull out an x, I get x cosine x plus 2 sine x. So for the AP exam, a lot of multiple choice questions will be fully simplified. When you're writing them, you do not need to fully simplify them if it's an open-ended question. So you can leave it like that, or just recognize that these two are equivalent. The tangent function can also be differentiated by using the definition of the derivative, but it's easier to use the quotient rule. So this is going to be one that you can memorize as well, but I'm going to show you how we arrive at it. So that way, if you forget it for a test or quiz or something, you can always derive it yourself. So if I want to find the derivative of tan x, so remember that, so d over dx just means the derivative with respect to x. So I'm taking the derivative with respect to x of tangent. I can rewrite tangent as sine over cosine. So what I'm really doing is taking the derivative of sine x over cosine x. So here we have a quotient, so we can use our quotient rule. So remember the quotient rule? We have low d high minus high d low, square the bottom, and away we go. So we're going to take the bottom, so cosine x, times the derivative of the top, so the derivative of sine x, oops, I just write sine. Derivative of sine x is cosine x, minus the top, which is sine x, times the derivative of the bottom, so the derivative of cosine x is negative sine x, all over the bottom squared. Okay, so I'm going to actually like multiply this out. So this is going to give me, so remember when I'm doing like cosine x times cosine x, I could write it like how I did on the bottom here with cosine x in parentheses squared, or it's the same thing as saying cos squared x. Same thing here. So I have a negative sine x times a negative sine x, so that's going to give me a positive sine squared x. And then on the bottom, I'm just going to write this as cos squared x. Okay, be careful here. You cannot cancel these out, even though there's two cosines here, or cosine squareds. You can't cancel them out. From our trig identities, cosine squared x plus sine squared x, that's equal to 1. And then the bottom we have cosine squared x. So 1 over cosine squared x is the same thing as saying secant squared x. So the derivative of the tangent of x is secant squared x. So that's one of those ones that you can remember. If you forget and you don't remember that it's the secant squared, you can change it to sine over cosine and then do the quotient rule and figure out the same derivative. Okay, so here is the list of all the derivatives of trig functions. So for all of the remaining trig functions like cosecant, secant, and cotangent, you can use the quotient rule in order to derive them if you forget what they are. Okay, so take a minute and write these down. And a little note for help with memorizing them is that every derivative of a cosine or a cofunction, so cosine, cosecant, cotangent, the derivative is always negative. So here we have derivative cosine, negative sine, derivative cosecant, negative cosecant cotan, derivative cotan, negative cosecant. So that kind of, if you forget if it's supposed to be positive or negative, anytime that you take a derivative of one of the c's, one of the cofunctions, you're going to get a negative. Okay, so let's look at this example. So the one on the top, we've got to take the derivative. So we're going to do f prime of x. So here we have a quotient. So we're going to use the quotient rule. So we're going to do the bottom, e to the x, times the derivative of the top. So the derivative of cotan is negative cosecant squared x. And again, use your chart from the previous slide if you need help. Minus the top, so that's cotan x, times the derivative of the bottom. So the derivative of e to the x is e to the x. all over the bottom e to the x squared. Okay, and then just to kind of clean this up a little bit, we can look at the top and we can see that there's an e to the x on the top for both terms, so we can pull out an e to the x. So we're left with negative cosecant squared x minus cotan x over e to the x squared. And then we can actually cancel out one of the e to the x's. So this will cancel out, and one of the ones on the bottom will cancel out. So our simplified answer, we have negative cosecant squared x minus cotan x over e to the x. Oops. Okay, and then let's look at this one on the bottom here. So again, differentiate, so that means find the derivative of. So we're going to have y prime. So here we have 2 times secant x. Okay, so technically if you wanted to use the product rule, you could, but because what's in front is a 2, that means that it's a constant. So if I did the product rule, when I take the derivative of 2, it's just 0. So we're just going to use the idea that the 2 is a constant, so that just stays in front, and take the derivative of what is next to it. So this is going to be, the 2 is going to stay. Derivative of secant is going to be secant tangent. So I'm going to do 2 secant x tan x. And then the derivative of cosecant is going to be negative cosecant x cotangent x. And then I'm just going to get rid of that double negative there. So I have 2 secant x tan x plus cosecant x cotan x. And there, oops, yeah, is our derivative. Okay, now we want to find an equation of the tangent line to the curve, y equals cosine x minus sine x, at the point pi negative 1. So remember, when you're finding the equation of the tangent line, your first thing that you want to do is you want to find the derivative, so that way we can find the slope. So I'm going to take the derivative of this. So y prime equals, derivative of cosine is negative sine x, and then I have minus the sine of x, so I have to take the derivative of sine, so that's going to be cosine, so minus cosine x. All right, that's my derivative. If I find the derivative at the point, so I'm going to use the x value of pi, that's going to give me my slope. So I'm going to do y prime at pi, so I'm plugging in pi for my x. So I have negative sine pi minus cosine pi. So negative sine of pi, that's just 0. And then cosine of pi is negative 1, so minus a negative 1 becomes plus 1. So I end up with 1. And that is my slope of the tangent line. So now I'm going to use my slope and the point that they gave us in point slope form. So y minus my y value, so minus a negative 1, that becomes plus 1, equals my slope of 1 times x minus my x value of pi. And you could solve this for y, or you could leave it just like that. So trig functions are often used in modeling real-world phenomena, in particular vibrations, waves, elastic motions, and other quantities that vary in a periodic manner can be described using trigonometric functions. So we're just going to look at one quick example. So an object at the end of a vertical spring is stretched 4 centimeters beyond its rest position and released at time t equals 0. Note that the downward direction is positive. So its position at time t is s equals f of t equals 4 cosine t. So that's our position function. Find the velocity and acceleration at time t. So if I want to find the velocity at t, that is just the derivative of the position. So that's going to be s prime, or in this case, they also call it f of t, so f prime of t. You're just taking the derivative of this. So I have the 4, which is my constant, so that's going to just stay. The derivative of cosine of t is going to be negative sine of t. So I'm going to have negative 4 sine t. Okay, that is my velocity. And if I wanted to find my acceleration, that's a of t, well, that's going to be the derivative of the velocity, or the second derivative of the position. So I'm going to look at my velocity, which is negative 4 sine t, and I'm going to find the derivative of that. So again, negative 4 is my constant. That's just going to stay on the outside. The derivative of sine t is going to be cosine t. So my acceleration would be negative 4 cosine